This is the newest project. I call it Bench Buddy. So let's go over how it works. So first of all, it works by putting the 3D printed shell on a barbell through the hole on the end like a clamp. And once you put it on the barbell, it's going to measure the speed of the rep, the acceleration, and the gyroscopic measures of the barbell. So let's go over what we can use these measurements for. So this is the ultrasonic sensor on the Bench Buddy. This measures distance. And if we use the derivative of position, we can get the speed. So if we measure the distance at one time interval, then wait X amount of time and measure the distance again and divide it by that time, we get the average speed for that moment of time. So that's why I plan to use this sensor for speed. And then inside the module right here, we have our GY521 sensor, which will measure the acceleration, and it's going to measure the gyroscopic forces. So we can use the acceleration to determine where our stucking point is in the lift, also where the acceleration is the least. We can also use acceleration to determine the speed if we take the integral of it, but that is typically less reliable than derivatives because of the C factor. So I figured I'll just put the ultrasonic sensor in there and take the derivative of that to find the speed to get a little bit more accurate reading. And the ultrasonic sensor can also tell us the ROM because it determines position. So if we subtract the highest position from the lowest position, we can get how many centimeters is the range of motion. Again, that can also be from the integral of the acceleration, which is speed, and the integral of the speed could give us position, but that would be so terribly unreliable that another sensor should be added so we can get a more accurate reading. And then also in the acceleration sensor, we have the three gyroscopic measurements. So that's going to tell us how much tilting we have of the barbell, if this tilts. It can also tell us if we tilt in the other directions too. So pretty much if our form's correct, that's what that's going to help measure. And then on the top right here, we have the little on-off button. I don't know if I have a battery in it right now. Don't. But we also have this LCD screen, and this is going to display some basic information, but I quickly realized it couldn't display all the information I needed. So let me explain. So the data we get from the sensors, if we plot out all of it, it's going to make some type of graph. So let's go with the acceleration sensor first. So we'll have time on the x-axis and then the acceleration on the y. So during the lift, and we'll have this as 0 so we can have a negative acceleration too. So when the barbell is on your back for a squat, let's say, you're gonna have some type of negative acceleration whenever you lower the weight, and then you'll have some type of positive acceleration like this whenever you're increasing the weight. And then it's going to happen again. So you're going to kind of get the sine wave if the acceleration stays relatively consistent throughout the lift. Only problem is we can't really display this graph on an LCD. And sure, we can get some of the high points. We can maybe, if we just tell the Arduino to say the highest number that I got, but then it won't tell us what the other rep's high point were. At least not with my knowledge of coding. So the LCD won't work to display this type of data. And also, the concentric is the part of the rep where you push upward, and the decentric is the part of the rep where you lower the weight. The decentric is not as important as the concentric because that is where muscles will be used to activate the rep. And that is only when the acceleration is positive, which is right here. So we don't care about the negative acceleration, we only care about the positive. So if we did one rep where we have this, it would be easy to measure it because there's only one of these. But if we do multiple reps, then we'll have multiple decentrics and concentrics, which would disrupt the data. Another thing I forgot to point out is, when will the Arduino know when the rep is being performed so it can start recording the data to start processing it so it can display the data on the LCD? You might think whenever the acceleration becomes negative, that's when the rep is starting. But if we turn the machine on before we do the rep, and then we have to unrack the weight, the acceleration is going to be like this at first. So it's kind of hard to read that. And then by the time it gets too low, so we know the rep is being performed, we already lost this much of the data right here. And that might not be that big of a deal if we're doing multiple reps, but if it's one rep, that kind of is. And then the same reason would be whenever the rep stops. So if we do one rep right here, which I'll just draw it, and then we'll have this before the acceleration's 0 again once we rack it. So how will it really know when the rep stopped? It's a little bit of noise, but I think I have a complex and interesting solution to this problem. So the solution is to put the LCD in a nice big trash can, because we don't need it anymore. We need a new type of screen that can display graphs so the human eye can perceive what data is valuable and then what data we just don't need to look at anymore. So we could use a accelerometer on our laptop, which has a serial plotter, which has the graph, but I don't want to carry my laptop into the gym. So I'm going to make an app instead for it. And I looked into it, and Apple is trash. It's terrible. Apple does not allow you to make apps easily because of the extensive amount of restrictions it has on the App Store, which is unbelievable. But Android does. So I bought a little Android phone. It didn't come in yet. It's going to come in later this week, and I'm going to code an app on the Android phone so it can be used for what I want to use. So pretty much all we need the app to do is to have different categories of graphs. So when you open the phone, we're going to have like graph 1, which is going to tell us the acceleration. 2 will be speed. 3 will be position. And let's see, we can have maybe like the 4 will be gyroscopic data. And then once we click on each of these, we can get the graph for it. And then that's just going to be the basic app. But if it's not that bad, I can make this into a whole workout app where you can keep track of your lifts and your progress. And it can keep track of this data too automatically. So I can just make a better lifting app than what's available in the stores right now. So you might be thinking, this is really cool, but why do we need the data of the acceleration, speed, position, and gyroscopic data on a lift? Like, is that important? I can make muscle without it. Well, I mean, you can, but we can do this. So the acceleration, whenever the acceleration is low and positive, that is where your sticking point is. So that is where it takes the most energy for you to complete the rep at. So on a bench press, most people's sticking energy is either at the beginning of the rep, in the middle, or at the end of the rep. And typically you know because you can feel whenever you're slowing down, but this can tell you by how much of a degree are you slowing down, which it could be useful. Another thing could be for like progressive overload. So typically you want to add more weight or reps, and that's progressive overload. But let's say on 1 week you didn't add more weight or reps, but you performed the rep faster. So your muscles technically got stronger because you performed the rep faster. You just don't know that. So you think you made no progress, but you did. So that's another way to make sure that all of our numbers are going up. And then position 2. So everybody complains about what, the range of motion, you know what I mean? So if you're a powerlifter, you want to decrease the range of motion. If you're bodybuilding, you want to increase it so you get the most amount of muscle hypertrophy. So this can also tell you, like if you're doing sumo or if you're doing conventional deadlift. It's my sumo guy. This is my conventional guy. It can tell you how much of a degree the range of motion changes. And then you can use that data to see which one's better for you. And then the gyroscopic data can help you to make sure that the barbell isn't tilted as you perform the rep, because then that's going to lead to muscle imbalance. So one leg will take more of the weight than the other leg, which will make it bigger. So it's kind of like having a little personal coach without hiring one. So the development of the Bench Buddy will be quite extensive, I'm not gonna lie. I've never coded an app before on Android, so the learning curve will be great. That's pretty much where most of it's gonna go into that. I forgot to mention too, we have these screws right here to help clamp the lifting buddy onto the barbell, and that's how we're gonna tighten it. This is the first design of it too, so I think the second design, I'm gonna take out the LCD, and I'm gonna add the Bluetooth sensor into it so we can connect to this thing and the Android phone. But I'm still gonna use this to prototype it with, and then try to print this on a nicer printer so we don't get all this kind of nasty residue on the bottom. But this will work for now.